where we take the decision on the features that are A, B, C in this case. So they just take only two values, 0 and 1. So we just check whether A is equal to 0 or equal to 1, then we just bifurcate our node here, and then next node is created. Again we take a decision, we go to the left or right. So finally we reach the class label. So that is how this decision tree will work. So we can extend the concept of binary tree to numeric values. So we can compare whether A is greater than B or some C is greater than D, and A plus B is greater than C plus D. So all these things are possible. So we took one example of a coin. There are 4 coins here, and one of them is heavier than other 3. So how to find out that heavier coin? So that was the question. So we just took a test whether A plus B is greater than C plus D. Some 2 coins were taken together and compared with other 2, and then we use a weighing machine to weight it, and whether this is heavier or this is heavier, that was checked. And finally we check that if this is heavier, then whether A is greater than B or not. So that was giving us the solution within 2 steps. Okay, so this technique can give you solution in 2 steps. Otherwise you can weigh all the 4 coins independently, and then you can find out who is heavier. So that could have taken 4 weighing steps. So instead of that, we can reduce it to 2 with tree structure. So each node in a binary tree or in a tree, decision tree, is implementing such kind of a rule. So if we choose any branch, say if I choose this branch, so what it is implementing, if it is checking actually if A plus B is greater than C plus D. If yes, and then if A is greater than B, then it is going to take the decision A. So that is the implementation of this particular branch. Then you have another branch like this, which will take decision for B. Then you have one more branch which takes decision for C. Then you have one more branch which takes care of D. So you can see that each branch from the root to leaf, if you travel, is implementing one sort of rule. Okay, so you keep this thing in mind. When you travel from this root to a leaf, it is implementing one rule. Now we have seen in a decision tree, each internal node in the decision tree is associated with a test based on one or more features. So here, suppose I take uh, a parallel axis test or axis parallel test. Here I am considering, say, y or y is greater than some threshold, then the implementation is this particular line. So whether you are above this line or below this line that we are checking, then it means that this set which was given to you, say this was complete set, this is called a data set. This is your data set, which is the complete samples belonging to 2 different classes. So if you partition that using this line, so you are making 2 sections. This side is one class and this side is another class. So that is possible with the help of comparison with y equal to theta. So if you are more than theta, you are this side of the plane, and less than theta, you are here. So this you can call it as class 1, and this you can call it as class 2. So to implement this, we require a node where you will take the value of your input and then you will check whether you are greater than theta. Yes, then you decide it as class 1, and if no, then you will decide it as omega 2. So this is a very simple implementation using this axis parallel test. So here your axis is now x greater than, so your test is x greater than theta, and then you take a decision yes or no. If it is yes, so this side, then you will say it's omega 1, and if this is greater than this, then it is omega 2. So your decision will be omega 2 here and omega 1 here. Now there was another way of doing this uh, evaluation at node. If you have data which is spread like this, so here I cannot have axis parallel test. That will fail here because it is checking one axis at a time. Okay, what is axis parallel test means? It is checking one axis at a time. So if you do checking here, so you can draw a line like this, or you can draw a line like this. Okay, so position may be anywhere, but this will not have a proper bifurcation of your data into two groups. Okay, so I need to have a line like this, which is bifurcating these two classes properly. So single check, that is if I check with respect to x or with respect to y, that is x greater than theta kind of test or y greater than theta kind of test, is not sufficient for this problem. Okay, so this problem is to be dealt with combination. So combination of features. So this is nothing but a line, and line equation is simple: y equal to mx plus c. Okay, so this kind of a line you can use, you can generalize that for n dimensional like this, and that will now implement this particular line, and then you can check whether you are this side of the line or this side of the line. You can say this is omega 1 and you can say this is omega 2. So this type of test is called a linear combination of features. So first was parallel axis test, and this is linear combination of features. Then we have seen this non-linear combination of features. So that is also possible, so that you can implement non-linear boundaries between two classes, so like this. Okay, so this is computationally most expensive, so we will see the simpler methods. So that was the first revision of last class. Now we will see an example of a decision tree. Now we have this data of some animals, and features are legs, horn, size, color, beak, sound. Okay, so we have taken, say, one animal and its characteristic values are written here. Okay, so for each animal we have different properties. So those properties are nothing but our features. So features are legs, horn, size, color, beak, sound. Okay. Now we want to construct a decision tree based on this data. Now, looking towards this data, this is not a unique solution. You can have your own solution. So we started constructing tree with number of legs as the feature. I feel that say, this is the most important feature, so that we can classify these animals properly. So this is the outcome. So here you will be doing classification. Okay, so this is outcome or classification. And this, from this to this is your input. These are features. So you can call collectively as feature vector X. Okay, so feature vector X consists of legs, number of legs, horns, present or not, and size, color, B, sound. So if you remember this, or if you have observed this table, you will see that non-numerical kind of data is now being handled. So when you say the probability of let's say probability of some X, and you assume that there is some data model being fitted over this data, say maybe normal distribution or some other kind of distribution, then this X is supposed to be a numerical data. So it cannot be medium or it cannot be small kind of data. You have to have some numbers, say X must be like this, say 0.1, 0.2 or 0.5 like this. So you are expecting some numerical data when you use data modeling. Okay, that we have seen in previous classes. But here you see a different kind of situation where we have data of this form. Okay. So this you cannot actually model on a mathematical basis, but you have to deal such kind of data in real life. So we have now, suppose number of legs as my feature number 1, and if I see this data, so since we are doing it manually, we are observing the things, and later on we will try to develop algorithm which will do like this. So this is say 4, 4, 4, 4, 4. So there are only two types of entries, either 4 or 2. So we have two branches here. Say number of legs equal to 4 or number of legs equal to 2. Now suppose I say 4, then I will travel in this direction. If it is 2, then I have to go this side. Then 4, we can check whether there is on present or not. If it is yes, then we will travel like this. If it is no, then we will travel like this. Okay. Then size of horn will have two categories. If it is small, then it is a goat. If it is medium, then it is a cow. Okay. So there are two possibilities here. Now, if there are no horns, then you have another set where you check size. Okay, size of the animal. So if it is small, then it is mouse, then medium, it is tiger, large, then it is elephant. So this size is the size of the animal. Now beak, whether beak is present or not, if yes, then you have three animals here. So crow, parrot, and sparrow. So depending on next feature, that is color, if it is black, then crow, green, then parrot, and brown, then sparrow. And there is no beak, but only two legs, then it is human. So our decision tree covers all classes. You can see here this leaf nodes, this bottom one. These are outcomes that we want. So these are all outcomes. Given input, Based on given input, we travel this path or we will travel this path. So depending on the situation, we will travel different paths, and then finally we will land to a leaf node. That is our decision. Okay, so decision is this last node. For example, suppose I say we want to test, suppose X test is, let us say there are 4 legs. Okay. On present, say no, then size is in medium. Okay. Then we have taken legs, on size, then color. So suppose you have some color like say brown. Okay, so and size is already given. So this is size, and say on is no, and suppose this is my data. I have given you this much data, and question is, what is this? Okay, so you travel on this tree. You have 4 legs, so you will go this side. Then you don't have horn, so you will travel up to this node. Then you check the size. So size is medium. So ultimately you are landing to a decision tiger. So this brown is not in picture, so that is not used for classification, but still data is with you. So maybe this answer is wrong, but this is how this decision tree works. Okay, so I don't think there is a brown tiger, but if it is the tree, then it will take this decision. So you have to then modify these trees so that you will cover all possible combinations of see these features, and still you are getting a correct answer. Okay, so there are various ways of constructing these trees. So what is our observation? Class labels are associated with each leaf node. Root to leaf represents a rule. Classification requires decision at each node. Features which are irrelevant do not appear in tree. So this is important. Both numeric and categorical features can be used. There can be binary or non-binary tree. A set of pattern is associated with each node, and rules are simple and easy to understand. So that is the beauty of this tree. So what are the weaknesses of decision tree? Design time would be large. The number of oblique splits possible would be exponential in the number of depending on that number of training patterns. So if you have complicated kind of data, then this time may grow because you will have many branches and many possible testings and so on. So how do you split your data is again an issue, and then where to split, how to split is again an issue. So simple decision tree axis parallel do not represent non-rectangular regions. So that is another problem. Say you can see this data which is actually possible to split using one line, uh, which is this one. So this is y equal to mx plus c, which is combination of two features. So if you take two features and make this combination, you can have only one node which will do this. So you can just write here, say whether y minus mx minus c is greater than theta or not. If yes, then say this side, then this is say omega 1. If no, then it means it is this side, so you will say omega 2. So combinations can solve your problem very easily. Otherwise, if you start or use only axis parallel method, then what we have to do is we can even solve that. Then we have to have one node which will take the decision, you are this side or this side. Then you have another node that will take this decision. Then you have third node which will take this decision. But still, you will see that in this cell, there is a mixture of two classes. Say majority is this blue, but I can then say this is blue region. Here I may have to say randomly that this may be blue or orange. Suppose orange. If I declare this as orange, then this is going to be misclassified. If I declare this as blue, then this is going to get misclassified. So there would be 100% accuracy here. Now, how to construct a decision tree? That is the next question. So we have one method called as CART, that is classification and regression tree. So the CART provides a general framework that can be instantiated in various ways to produce different decision trees. So in the CART approach, 6 general questions arise. That is, should the feature be restricted to binary or multi-valued? Shall I say yes, no type feature or multi-valued feature? That is one question. Which feature should be tested at a node? So given a node, suppose I started with lex equal to 4 or not. So how do I came to know that I should test this first? Why don't you test color first? Okay, so that may be the question. So how do I decide which feature is to be tested first? Then next question is, when a node is declared as leaf node, a node is to be declared as leaf node. So you are splitting things into different nodes, and then different nodes are created. Then suppose I create this one, then shall I declare it as leaf node or not? Who will take this decision? Whether this was leaf node or not. Okay. So if once you declare some node as leaf node, there won't be further branches to that. Okay. So that thing you keep in mind. So we have to take that decision. Now how to simplify a tree if it is getting complicated? So when you start implementing the algorithm, you find that okay, this tree is growing very big and you are not able to take a proper decision where to stop, or if you stop at some point, then how to miniaturize or small, how to make this trees as small as possible. So that is another question. If leaf node is impure, how to decide leaf class? So that we have seen right now here. So when I declare this as one zone, so it is actually representing one branch of that node. So when you are within this zone, you say yes, then you will see that there is a mixture of blue class and this orange class. So then what is finally class of this area? So I can just take a decision based on say majority. So majority is blue, so I say it's blue. So that is another important issue. And how to handle missing data. If at all some features are not present, then how to handle this missing data. So that is another question. Now you have a test. So in your class that is active, you join that test. It will take 15 minutes. So I hope all you will attend. So it is based on the last week's topic. So okay, join that test here. Use your classroom and join it. So link is active there now. So link will remain active for only 15 minutes. So join immediately. It's a small test of 5 marks.